Okay, in this video we are going to talk about the unit circle. So it's just an introduction to the entire concept, and then we're going to end up filling one in. So let's get started. You actually end up starting not with the unit circle, but actually with the special right triangles that hopefully you remember. You probably first saw them in geometry, I guess. We're going to review them because they're going to be really important to kind of deriving everything about the circle. So the first one is going to be a 30, 60, 90 triangle. But really at this point in math, you want to switch from degrees to radians. I always think of these in terms of degrees, but for our purposes, we really want a pi over 6, pi over 3, pi over 2 triangle. I basically never say that, but that's really what we're talking about. So we need a triangle. So we got this. Our angle that we're going to focus on is the pi over 6 angle, so that's the 30-degree angle. And then the ratio, the side opposite 30 is x. The side opposite 60 and 60 and pi over 3 are equivalent is going to be x root 3. And then the hypotenuse is 2x. So what's going to be really important for us with this triangle is to answer the question of what happens if the hypotenuse is 1. So if the hypotenuse is 1, and that's 2 times x, then x must be 1/2, and that's the side opposite pi over 6, so that's 1/2. And then the side opposite pi over 3 is x root 3, or 1/2 of root 3, or root 3 over 2. Okay, so that's our 30, 60, 90. We're going to use that a bunch. So the next thing I'm going to do is kind of weird. I'm going to look at a 60, 30, 90 triangle, which is obviously the same triangle, just kind of like rotated, but we're going to need it a bunch, so I think it's good to just kind of like get it done. So it's our pi over 3, pi over 6, pi over 2 triangle. Here's the triangle. This is our pi over 3 angle. And then the side opposite pi over 6 is still x, so I'm actually going to fill that in first. X root 3 and 2x. And then we again want to answer the question, what happens if the hypotenuse is 1? Well, it's the same thing as what we just got. So let's fill it in. So if the hypotenuse is 1, side opposite 30, or pi over 6, is 1/2, and then we get our root 3 over 2. Okay, so that's 2 triangles that we're going to use extensively. And then the remaining triangle is 45, 45, 90, which in radians, we would say pi over 4, pi over 4, pi over 2. Again, I've never really heard anyone talk about them that way. I think almost everyone memorizes them in degrees and just kind of like goes with it. So a triangle. Our angle is pi over 4. The side opposite is x. So the other side is also x because it's an isosceles triangle. And then this is x root 2. So those are our ratios. But again, we're really only interested in if the hypotenuse is 1. So if the hypotenuse is 1, we get a 1 here. So that means that x root 2 is equal to 1, which means x is 1 over root 2. But for kind of like historical reasons, we're going to rationalize this. So I'm going to multiply by root 2 over root 2 and end up with root 2 over 2. So those are the 2 legs of this triangle. So there and there. Okay, that was all prep work. And now we're ready to actually talk about the unit circle. So that's going to come up again. So the unit circle looks kind of like this. It's just a circle. It has an equation, which you'll end up using sometimes. We're not really going to use it in this video, but it's an important relationship that x squared plus y squared is equal to 1. So every ordered pair that's on the circumference of this circle, if you substitute x and y in there, square them, add them up, you will definitely get 1. That's a big deal in trig, but not for the purposes of this, really. Let's see. I'm going to fill in some angles. So that's 0 radians, or degrees, it doesn't matter at this point. I'm going to say 0 radians. This is pi over 2. This is pi, which is 180, and it makes a straight line. So like that's familiar, hopefully. And then 3 pi over 2. And then back at 0, we can also think of that as 2 pi. Okay, so those are the angles. Those are called quadrantal angles because they divide up the quadrants of the xy plane. So we got 0, pi over 2, pi, 3 pi over 2, 2 pi. I call them the pi over 2 angles frequently also because they're at right angles to each other. Now let's fill in some ordered pairs. So right there, we got the point 1, 0. Here we got the point 0, 1. All this is because the radius of the circle is 1. This will be negative 1, 0. And this will be 0, negative 1. Okay, so one thing that we're kind of getting here, without really doing much, is that each of the points on the circle seems to be associated with one of the angles on the circle. So like the ordered pair 0, 1 is associated with the angle pi over 2. The ordered pair negative 1, 0 is associated with the angle pi. So that's a big deal. So the points on the circle are associated with the angles on the circle. So now let's try to answer a new question. What if I took a 30, 60, 90 triangle and put it on the circle, right? So that's a pi over 6, pi over 3, pi over 2 triangle. And one thing that I know is I know that the radius of the circle is equal to 1. And because of the way I put the triangle on here, that means that the hypotenuse of the triangle must be equal to 1. And that's why when we looked at the ratios before, we focused in on what if the hypotenuse was 1. So we actually already know what to fill in here. So I'm going to fill in pi over 6 because that's the angle. I know that the hypotenuse is 1. I found that when the hypotenuse is 1, the side opposite is 1/2. And then the side adjacent to pi over 6 was root 3 over 2. But now think what's happening, right? So the distance from the origin along the x-axis is root 3 over 2. The distance from the x-axis up to the point on the unit circle is 1/2. So I can actually fill in this ordered pair as radical 3 over 2, 1/2. That's a big idea. And now let's take a look at just the right triangle, right? So in that right triangle, if I try to do some trig on it, I can find the sine of pi over 6. So the sine of pi over 6 should be opposite over hypotenuse from our right triangle stuff. And in this case, opposite is 1/2. Hypotenuse is 1. That's key, right? Because that means that really on the unit circle, the sine of pi over 6 is just going to be the side opposite pi over 6. So 1/2. And then the cosine of pi over 6 is going to be adjacent over hypotenuse. But again, the hypotenuse is 1, so this simplifies really nicely. So I get radical 3 over 2 over 1, which is just radical 3 over 2. So it looks like the ordered pair on the unit circle that's associated with pi over 6 is radical 3 over 2, 1/2. And we found that that's actually the cosine of pi over 6, comma, the sine of pi over 6. So this is a relationship that we're going to use like a million times probably, where it looks like the ordered pair on the unit circle corresponding to the angle is the cosine of that angle, comma, the sine of that angle. Okay, we can take our triangle and we can just reflect it a bunch. So I'm going to reflect it over the y-axis, and then I'm going to reflect over the x-axis. I'm going to end up with this picture. And I know that this is pi over 6. I know this ordered pair is radical 3 over 2, comma, 1/2. I also know that that's the cosine and the sine of pi over 6. Cosine of pi over 6 is root 3 over 2, sine is 1/2. So let's just use symmetry to fill in the other ordered pairs. So here, this should just be negative root 3 over 2, 1/2, because we reflected over the y-axis. I'm going to take that ordered pair that I just wrote and reflect it over the x-axis. So the y-coordinate will become negative. So negative root 3 over 2, negative 1/2. Reflect, it doesn't really matter which pair I'm reflecting at this point. I end up in the fourth quadrant, radical 3 over 2, comma, negative 1/2. Okay, so that's filled in. But now the question is, like, what are these angles? Well, I know that those four angles are all equal. They're all pi over 6. I know that that is pi, right, because it forms a straight line from 0. And so the angle in the second quadrant by the ordered pair negative root 3 over 2, 1/2 should just be pi minus pi over 6, right? We almost rotated all the way to pi, but we stopped pi over 6 short. Pi minus pi over 6 is 5 pi over 6. I can do the same sort of thing in the third quadrant. It's like we went pi and then another pi over 6, so if I add those, I will get 7 pi over 6. In the fourth quadrant, it's a little different. There's two ways to think about it. So I'm going to think of, instead of thinking of 0, I'm going to think of 2 pi. I'm going to think I almost went all of 2 pi, but I was pi over 6 short. So 2 pi minus pi over 6 is 11 pi over 6. And then it's important to realize like how we got to these angles. So what we're doing is we're always starting at 0 and rotating. So there's 5 pi over 6. Then you go back to the positive x-axis, rotate around to 7 pi over 6, go back to the positive x-axis, rotate all the way around to 11 pi over 6. So those are the angles that we're referring to. And from our picture, we've already figured out that on the unit circle, when we have the angle, the ordered pair associated with that angle is the cosine of the angle and the sine of the angle, which means that I now know the cosine and sine of all of these pi over 6 angles, all the angles that have a 6 denominator. So cosine is negative root 3, 5 pi over 6 is negative root 3 over 2. Sine is going to be positive 1/2. And then we can keep going, right? So we got 7 pi over 6, cosine, negative root 3 over 2. Because in the ordered pair, that's the x-coordinate. Sine is going to be negative 1/2. Because in the ordered pair, that's the y-coordinate. And then we can do 11 pi over 6. So we're building it up. We're going to find all of the simple, I call them famous angles. It's all the famous angles that fit on the unit circle. We're going to find their sines and cosines. So to do that, we're going to use our other triangles, right? So we also looked at a 60, 30, 90. Let's put that on the unit circle. Let's fill in, right? So the hypotenuse is definitely 1. Then we found that the side adjacent to pi over 3, I should say, which is 60 degrees, was 1/2. And opposite was root 3 over 2, which gives us that ordered pair as 1/2 comma root 3 over 2. And we know that that represents the cosine and the sine of pi over 3. So the cosine of pi over 3 is positive 1/2, because that's the x-coordinate. And then the sine is going to be radical 3 over 2, because that's the y-coordinate. Okay, what's sort of interesting, we're not going to talk about it too much here, but you might notice that the ordered pair we just wrote on the unit circle just flips the x and y coordinates of the ordered pair we wrote for pi over 6. And that has something to do with the fact that pi over 3 and pi over 6 add up to pi over 2. So 30 plus 60 is 90. They're complements of each other, but we're not going to talk about that too much here. Okay, let's go through and do the same thing. We're going to reflect, 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 write ordered pairs, figure some things out. So we've got all of our triangles. I'm going to fill in this one, which we knew, right? Pi over 3 is associated with the point 1/2 root 3 over 2. So we know the cosine of pi over 3 is 1/2. The sine of pi over 3 is root 3 over 2. That ordered pair is like the key to understanding this. So we have this. I'm going to reflect and then reflect again and reflect again. So that's just using symmetries, which is a good thing to do, right? I mean, if you reflect over the y-axis, you change the sign of the x-coordinate. If you reflect over the x-axis, you change the sign of SIGN, I should say, of the y-coordinate. And now if I can figure out the angles, I know the sines and cosines, or the cosines and sines, of more angles. So let's do the same thing. So this is pi, and I know that the 4 angles at the origin that make kind of like a bow tie are all pi over 3s. So pi minus pi over 3 is going to be 2 pi over 3. And then in the third quadrant, it's like I went pi and then another pi over 3, which will take me to 4 pi over 3. And then in the fourth quadrant, I tried to go all the way to 2 pi, but I was pi over 3 short. 2 pi minus pi over 3 is 6 pi over 3 minus pi over 3 is 5 pi over 3. So these are the pi over 3 angles. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. They're famous angles. They have nice sines and cosines. Let's write them down. So based on the ordered pair associated with 2 pi over 3, I know the cosine of 2 pi over 3 is negative 1/2, and the sine of 2 pi over 3 is radical 3 over 2. Now let's look at 4 pi over 3. The ordered pair is negative 1/2 negative root 3 over 2. So I know the cosine is negative 1/2, and the sine is negative root 3 over 2. Let's jot that down. And then look in the fourth quadrant. We have 5 pi over 3. That's associated with the ordered pair 1/2 comma negative root 3 over 2. So I know the cosine of 5 pi over 4 is 1/2, and the sine is the sine of 5 pi over 3 is negative root 3 over 2. And let's write that down. Okay, all of this is from the special right triangles that we looked at, but we're getting these values, and you're seeing 1/2 root 3 over 2 coming up all the time, which makes it easier to memorize than it initially looks like it'll be. And let's keep going. Let's do the other triangle that we know, right? So we also know 45, 45, 90, which is really pi over 4, pi over 4, pi over 2. We found, so we got pi over 4, we got a hypotenuse of 1, and then we found this one was a little trickier. We did like x root 2 is equal to 1, so x is 1 over root 2, which is definitely how some people memorize that, but I just didn't, and I have trouble breaking that habit. So I rationalize it and call it root 2 over 2 and root 2 over 2. And that triangle gives us our ordered pair of root 2 over 2, root 2 over 2, which tells us the sine and cosine of pi over 4. I should really always say cosine and sine because on the unit circle, the x coordinate is cosine and the y coordinate is sine. They're in alphabetical order. X and y are in alphabetical order, and so are cosine and sine. That can be helpful if you're having trouble remembering that. So from this ordered pair, I know that the cosine of pi over 4 is root 2 over 2. The sine of pi over 4 is root 2 over 2. We get both of those just from putting that triangle into the unit circle. All right, so I bet you know what we're going to do. We're going to reflect, reflect, reflect. So let's do that. We get these. Each of the 4 angles at the origin with the x-axis are pi over 4s. So let's fill in, we found this ordered pair, root 2 over 2, root 2 over 2, and then that's pi over 4. People find the pi over 4 is the easiest to remember because the x and y coordinate are the same. It's just like, is it positive or negative that you have to think about? Okay, so let's figure out the ordered pairs. We've got pi and 2 pi, just filling in things we know. So reflect over the y-axis gives us this. Reflect over, and then that's 3 pi over 4. It's hard to remember what order I do these in sometimes. So it was, you tried to go all the way to pi, you were pi over 4 short, pi minus pi over 4 is 3 pi over 4. Okay, new quadrant. We're reflecting over the x-axis. So negative root 2 over 2, negative root 2 over 2. In the third quadrant, we're finding sine and cosine are always both negative. In the second quadrant, we're finding that sine is positive, cosine is negative. In the fourth quadrant, I guess, we're finding that cosine is positive, sine is negative. That's happening because cosine is x and sine is y. And just look at the quadrants and think like, is x positive or negative? Is y positive or negative? It's not that bad to remember. So this angle in the third quadrant, to get back to that, we went pi and then another pi over 4. So that takes us to 5 pi over 4. And finally, let's move into this quadrant. So root 2 over 2 and negative root 2 over 2. And then we tried to go all the way to 2 pi, but we were pi over 4 short, so 8 pi over 4 minus 1 pi over 4 is 7 pi over 4. And now we know the sines and cosines, or cosines and sines, I should say, of these pi over 4 angles, right? So we found cosine of 3 pi over 4 is negative root 2 over 2. Sine of 3 pi over 4 is root 2 over 2. Also, all of these are on the lines y equals x and y equals negative x, which sometimes comes up. It's just helpful. Like, the more you think about it, try to relate it to things you already know, the better off you'll be. So that's 3 pi over 4, 5 pi over 4. Remember, it's cosine comma sine, and the ordered pair is negative root 2 over 2, negative root 2 over 2. So we get that. And then 7 pi over 4, we get cosine of 7 pi over 4 is positive root 2 over 2, and sine of 7 pi over 4 is negative root 2 over 2, because we're just reading the ordered pairs. So on the unit circle, the ordered pairs are cosine, sine, and then you just have to remember a couple of ordered pairs. There's only like 3 that really show up, plus the quadrantals, but those are the easiest ones, right? Like 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay, let's just put the whole thing together, right? We're going to fill the whole thing in. So what I'm going to do is I'm going to start with the angles because I always start there. We get 0, pi over 6 because it's the closest to the x-axis, pi over 4 because it's in the middle, pi over 3 because it's just the next one that you write, pi over 2 because it's quadrantal, And then just think about the symmetry, right? So the angles that are the closest to the y-axis are going to be your pi over 3s. The angles that are the closest to the x-axis are going to be your pi over 6s, and then the ones that are on y equals x, y equals negative x are your pi over 4s. So what I've got so far is 0, pi over 6, pi over 4, pi over 3, pi over 2. Coming next will be a pi over 3, but in the second quadrant, 2 pi over 3. Then a pi over 4, then a pi over 6, and then a quadrantal, which is pi. Now another pi over 6 is 7 pi over 6, another pi over 4, so 5 pi over 4, another pi over 3, and we're closest to the y-axis again, so that makes sense, 4 pi over 3. Another quadrantal, 3 pi over 2. A lot of people mess that one up and write 2 pi over 3. Don't do that. I mean, that's like not really advice, but I see it a lot. Try not to do it. So we're going to be the closest to the y-axis is a pi over 3, so 5 pi over 3. Another pi over 4 is 7 pi over 4. And then another pi over 6, so 11 pi over 6. Now, also 0, you sometimes want to fill in as 2 pi because it's the same. They're called coterminal angles. They end in the same place. And it's useful to think of it as 2 pi because in that fourth quadrant we keep doing 2 pi minus kind of that little angle at the x-axis. Let's do the ordered pairs. Okay, so the first point is just, an Algebra 1 student would look at it and be like, that's point 1, 0 because the radius is 1. And now we have to fill them in, right? So we're going to go from the biggest x-coordinate that we write down to the smallest. So the biggest one, we're writing either 1/2 root 2 over 2 or root 3 over 2. Root 3 over 2 is the biggest one, so we're going to start with that. So it's root 3 over 2. If you write root 3 over 2, the other coordinate has to be 1/2 because those always go together. And you've got that point. If you get that point right, you will get all of the points right. So make sure you're getting that right. After the quadrantal, it's the biggest x-coordinate you can have, which is root 3 over 2. And if you write that, you have to write 1/2, and now you're just good to go, right? So we're going to get a little smaller, root 2 over 2. If you write root 2 over 2, you have to write root 2 over 2. It might be positive or negative, but they always go together. And then we already wrote root 3 over 2, so the next one is just going to be at 1/2. So 1/2 root 3 over 2. And the points that go with pi over 6 and pi over 3 just are you just reverse the x and y coordinates. So make sure that's happening as you fill it in. And then another quadrantal. And now we're just kind of like off to the races, right? Because we have the points, we're just reflecting. I tend to, when I'm filling this in, like for speed, all I do is think about the x-coordinate. Am I getting the x-coordinate right? If I am, I kind of have no choice about the y-coordinate, so I know that it will also be correct. So we just fill in. And I'm writing these pretty slowly. You kind of, hopefully you get the point at this point. Quadrantals. People forget to label the quadrantals all the time. So in my class, I make everyone fill this in a lot because I really want you to memorize it and be able to just access it whenever you need it. And finally this. So this is a completely filled in unit circle. It's got all of the points, all of the angles in radians. We're not going to fill it in degrees. We kind of want to like leave degrees a little in the past. So some of the things that we found, we know that all of these ordered pairs are cosine theta, sine theta. So just like looking at it, you see 5 pi over 6, you think cosine of 5 pi over 6 must be negative root 3 over 2, sine must be 1/2. Because you're starting to memorize it, it should be starting to like be a picture that you just kind of see in your head. If you get to that point, it's so useful. Okay, I want to highlight though, that ordered pair means that x is equal to cosine of theta and y is equal to sine of theta. On the next page, I'm going to do 2 problems that are kind of related to really hammering in that idea. So x is cosine, y is sine. And then another thing that you have probably noticed, you just use 1/2 root 2 over 2 and root 3 over 2 over and over again. You basically aren't writing anything else other than the quadrantals, but no one really messes up the quadrantals. What people do is they forget to label the quadrantals. And then another important thought here is with those 3 numbers, 1/2 is smaller than root 2 over 2, which is smaller than root 3 over 2. Which means if you're as far as you can get, other than the quadrantals, if you're as far as you can get from the from the y-axis, I should say, you know that the x-coordinate must be root 3 over 2. So look at that. The pi over 6's, they all have x-coordinates that are, the absolute value of their x-coordinate is root 3 over 2. They're the farthest from the y-axis. Similarly, if you're the farthest from the x-axis, you will get the biggest y-coordinates you can have. So the y-coordinates of the pi over 3 angles are all root 3 over 2. I use that kind of like geometry, I don't know, like the spatial reasoning to figure a lot of these out. And then I definitely recommend just get some blank copies of this. There are some on my website somewhere in the description of the notes, I guess, and fill it in over and over again. So I like my students to aim for about 90 seconds, try to get under 90 seconds. And that just means if you can, and you can definitely do it, it just takes practice. It seems impossible at first. Your first one will be really slow. Just do it again. Don't even like study or anything, just do it again, and you'll be like 50% faster. You can definitely do it. Okay, so I'm going to, if you can, I was going to say, if you can do it in under 90 seconds, then no matter what you are doing, if you get confused, you get lost, you can just draw your own unit circle, and in 90 seconds you will have all of this information available to you, and you don't have to keep it in your head anymore, which is why we want to be able to do that. All right, let's do 4 sort of simple representative problems of things you'll be asked, just to give you an idea, right? We did all of this deriving. Let's at least like do something with it. So first thing we're going to do, we're going to find the cosine of 0 radians. So I'm immediately thinking, where is 0? That's that point to the far right. What ordered pair goes with it? 1, 0. I know on the unit circle, x is cosine, so I know the cosine of 0 is 1. A similar problem would be, let's find the sine of 4 pi over 3. Think of all the angles that you know. So the pi over 3's are the closest to the y-axis. 4 pi over 3 is bigger than pi, so it's going to end up, you could get this wrong, but it's going to be in the third quadrant. So 4 pi over 3 is right there. What ordered pair is that? Well, I'm the closest to the y-axis, so I should have the smallest x that I'll write, which would be 1/2, but negative because of the third quadrant. And then if I write 1/2, I have to write radical 3 over 2, but negative because I'm in the third quadrant. And then I know that on the unit circle, it's cosine sine, so I know the sine is negative root 3 over 2. But what I really do when I solve that is I just picture the unit circle, and I think, what's the y-coordinate there? I don't like run through all of that, but that's because the unit circle has just like become a part of my memory. I don't really need to think about it that much. It's available whenever I need it. The next problem is cosine of x equals negative root 3 over 2, where x is between 0 and 2 pi. So I know on the unit circle, cosine is the x-coordinate. So this, don't get confused. That x is just a variable in the problem. It could be cosine of theta, cosine of y. It doesn't really matter, cosine of z. So it's saying cosine of some angle is negative root 3 over 2. So I know that cosine on the unit circle is x. So I'm saying basically, where is x negative root 3 over 2? I'm just going to draw a vertical line where that happens. I know the x-coordinates of all of the points around the circle, and negative root 3 over 2 happens right here. Those are the closest to the x-axis, so they're the pi over 6's. So I know this is 5 pi over 6, and I know that this is 7 pi over 6. And so I know the solutions to this equation. So we just solved the trig equation using the unit circle. We got x is 5 pi over 6 and x is 7 pi over 6. Let's try the next one basically the same way. On the unit circle, sine is the y-coordinate. So I'm just going to draw a line at y equals negative 1/2. I know the y-coordinates of all of these points, so I know that negative 1/2 is going to be here. Also, I know that the very bottom of the circle is negative 1, so just split that in half and draw it. So this again is going to be pi over 6 angles. I already identified 7 pi over 6. This angle is 11 pi over 6, so my answers here are 7 pi over 6 and 11 pi over 6. Those are just like small examples of how you can use the unit circle to answer these sorts of things, because we spent a lot of time deriving. Just wanted you to see it, get a sense. All right, so maybe go back, screenshot that unit circle, get a bunch of blanks, fill them in, practice it until it's like second nature, and it will pay off for a very long time. All right, I hope you found this helpful, and good luck.